Hi Geometry, this is Miss Craft. Today we're going to be talking about solving systems using elimination. Our objective is to solve a system of two equations by eliminating a variable and solving for the other. Although we have not actually graphed two systems, we've been talking about graphs of two equations in a system. And so we know that the intersection of those two lines is the solution to a system, which comes in a point x comma y. We know that during substitution, when we take one equation and set it equal to either x or y and plug it into the other equation, that we also come up with a solution x comma y. And our third technique is going to be elimination. So during elimination, we're going to be manipulating the equations algebraically. It just works a little bit differently than substitution. And again, we're going to come out with an x value and a y value. And in all three of these ways, we are doing the same thing, finding the same solution, just in different methods. So this is a good screen to pause at and maybe take some notes, or just have as a picture on your phone if you get lost. Our first step is going to be to line up the variables, and I will show you what that means on the next slide. Second step will be to multiply one or both equations by a value that would create opposites for the variables. Third step is to combine those equations, which ends up eliminating one of the variables. When one variable is eliminated, we're left with one variable, and then we can solve for that one. Once we solve for that one, then we use substitution to plug it back in to find the other variable. All right, so let's put those steps to work. So here is our first problem. We have 4x plus 3y equals 14. Here's what I want you to know about this, is that this x here is lined up with this x. This y is lined up with this y, so it's above, they're above each other. And then we have our equal signs lined up, and then we have our constants on the other side lined up. Now, it does not have to go x and then y and then our constants. These can be y first and then x and then our constants, or our constants can be on the other side of the equal sign. But however they are, they have to be lined up. Okay? The next step, we need to look for some variables that could cancel out. So to cancel out, we mean they have opposite signs and the same coefficient. So the coefficient of this one is 1. The coefficient of this one is 3. If I were to add or subtract those, they don't go away, right? In this case, I have a positive 3y and a negative 3y. Now, they have opposite signs and the same coefficient and the same variable. That means if I were to add these two equations together, like a big addition problem, that these guys would be eliminated. So the y's would go away. Okay, so that's what we're going to do. We have 4x plus 3x gives us 7x, plus 3y minus 3y gives us nothing. They become eliminated. So really plus 0, right, if you wanted to. And then 14 plus 28 gives us our 42. And now we can solve for x. Now we only have one variable. So this is 7 is being multiplied to x. So to undo that multiplication, we have to divide. And what we do to the left, we have to do to the right. Okay, 7 over 7 is 1, and that gives us 1x, because that's what we really want to know, is 1x. 42 divided by 7 is 6. Now, many of you will want to be done at that point. We are not done. Okay, we have our x, but remember we're solving for x, comma, y. We're solving for a point. So we've got to pick one of these equations, it doesn't matter which one, and plug this 6 in for the x. Okay, so I'm just going to write my equation down. I have 4 times something plus 3y equals 14. Now, really what I'm plugging in there is what I found here, my 6. Okay, so 4x, which x is now 6. 4 times 6 is 24, plus 3y equals 14. Now, when I subtract this 24, I want this y to get by itself, so we have to subtract 24 from both sides. And when y is by itself, it is 3y. And 14 minus 24, use your calculator if you need to. You're going to get a negative number. It's negative 10. Now, I want 1y, and I actually have 3 y's here. So I know the opposite of multiplication is division, and that 3 over 3 is 1. And what I do to the left, I have to do to the right. So now I know y equals negative 10 thirds, which you can put in your calculator and get a decimal if you want to, or a mixed number, but I'm just going to leave it like this. So the two pieces that I want, the two pieces of information that are good to me, are my x and my y. So here we have x, comma y, and that is our 6, comma negative 10 thirds. So where do these two lines intersect? They intersect at 6, negative 10 thirds. Okay, now is a good time to pause and see if you can do this one on your own. I am going to do it out loud, but you can always fast forward me and move at your own pace. Okay. All right, so in this case, let's see what we have here. We've got our x's lined up. We have our y's lined up, equals sign, and our constants. From this point, we need to try and get these to be opposites. So I know I can get a 2 and a 3 to match up at 6, right? If I multiply this top equation by 2, I can multiply the bottom one by 3, and then this would be negative 6 and positive 6. The problem with that is I have to multiply both equations by numbers. So I'd rather only multiply one equation by a number. So here we have 5y and 1y. I think that makes it a lot easier to just multiply this by negative 5, right? Because I want this to be negative 5y, so they cancel out. Okay, so you're going to have your negative 3x. I'm just copying the equation from the top first, equals 6. And then I'm going to have negative 10x minus 5y and equals 85. Whoops, negative, positive. Positive 85. A negative times a negative is a positive. Okay, are we ready? Let's add those guys together. So when we add them together, we're going to get negative 13x, 5 minus 5. That eliminates, which is good because that's what we wanted it to do. And then we're going to get our 91. Now, from here, you can divide by your negative 13, divide by your negative 13. And when we have 1x, it is going to equal negative 7. Okay? Now, we've got to plug in again. So we've got to take this guy and plug it into one of the equations up here. Let's do the bottom one. So let's do 2 times, this is where I put that negative 7. I substitute negative 7 in where I see x, plus y equals negative 17. Now I multiply. I have negative 14 plus y equals negative 17. And then I add 14 to the other side. I forgot to change colors. I add 14, add 14. Those go away. Y equals negative 3. Don't forget to use your calculator if you need to. So my answer here is negative 7, negative 3. So these two equations intersect at the point negative 7, negative 3. All right, why don't we move to the next one? We've got one more here. So this one has fractions. If you're like my 5th grader or any other student, you'd prefer not to work with fractions. So I'm going to show you how you cannot work with fractions. 2/3 has a denominator of 3. So remember when we are multiplying fractions, we multiply them straight across. So if I want to get rid of 2/3, What's the opposite of dividing by 3? Well, that's to multiply by 3, right? So if I were going to multiply this by 3, I could multiply straight across, and I could get 6 over 3, right? Or I could see that these are going to cancel out right away, and really 6 divided by 3 is 2. Okay, so it's magic that you can do to get rid of the denominator. However, you cannot just do it to that fraction. You've actually got to do it to your entire equation. So we want to multiply this entire equation by 3. So what do you think we would have to multiply the bottom equation by to get this fraction out of here? Well, the opposite of dividing, right, because a fraction is just division, the opposite of dividing something by 6 is to multiply it by 6. Okay, so we're going to change what these equations look like really quick. 3 times y is 3y. 2/3 times 3 we figured out is 2x. See how that fraction's bye-bye now? Minus 9. Our bottom equation, we're going to distribute this 6 in there. We're going to have 6y equals, well, negative 5 over 6 times, whoops, that's not a times 6 over 1. Well, I can see the 6's are going to cancel out right away, but if I don't, I get negative 30 over 6, which is really just negative 5, right? So now I have negative 5x plus 36. Now we can do some work. So these are our two equations we want to work with, and I can see that my x's and my y's are lined up, right? I've got y's here, I've got x's here, and my constants here. My equal sign is lined up. So let's go ahead and change one of our equations. I think that by changing this equation on the top, by multiplying by 2, we can get our negative 2, sorry, we can get our 6's to line up and eliminate. So I'm going to pause. I'm going to do all of the work. You guys should pause too. See if you can do this one on your own, and then check your answer with me at the end. All right, so what happened here is we multiplied, and so I went from here to there. And then we just copied this guy down here on the bottom. Don't forget your signs. So this one turned to a negative, this one turned to a positive. We simplified down. I ran out of room down here. We divided by 9. And then we got x equals 6. Don't forget you need to plug that back in. You could have plugged it into this equation, or the ones that we manipulated. To not work with fractions, I went ahead and plugged it into this guy. And you can see my work here. We got y equals 1. So where these two lines intersect is the point 6, 1.